Right triangle trigonometry, C1. Explain how the right triangle can be solved. Well, this is the most important question in this set of videos. Let's try to understand it, okay? When we say explain how the right triangle can be solved, first we need to understand the word solution of right triangle. What do we mean by solve the right triangle? So let's make one right triangle here. Let's say this is our right triangle. So that means this angle here we're talking about is the right triangle. Let's say let the triangle be ABC, where C is the right triangle. Now when we say solve the right triangle, then what do we understand? We understand by solving means first find all sides, find measure of all sides, 3 in this case, right, for a triangle. And second, we need to find value of each angle. Now since it is a right triangle, we know at least one angle, which is 90 degrees. Here in this case, angle C is 90 degrees. So that is what we mean by saying solve right triangles. Now the question here is how to solve right triangles. So to solve right triangles, we should be given something, right? So there could be two cases. So we'll consider two cases of what should be given to solve, or what should be given at least to solve the right triangle. So at least we should know one of the two things. So first, either we know two sides of a triangle. So one is we know any two sides of triangle. That is one case. If we know two sides of a triangle, let us say in this triangle we know sides, this side is A, let me write, this side is B, and let's say this side is C. So if we know two sides, let's say A and B, we can always find the third side, C, right? Then how can we solve? Then we know C square is equals to A square plus B square. So knowing any two sides, we can always find the third side. So that helps to find measure of all the sides, correct? So two sides are known, so we can find the third side. Now, if two sides are known, how are we going to find each and every angle? We only know one angle. Well, we can now use sine ratio, cosine ratio, or tangent ratio. In short, trigonometry to solve the triangle. Trigonometry is all about solving triangles, right? It's measurements of triangle. That is what the word trigonometry really means, right? So it helps to solve a triangle. Now, as you know, sine theta, right? So first, let me give you that acronym. Sine is opposite over hypotenuse, correct? Cosine is adjacent over hypotenuse, and tangent ratio is opposite over adjacent, correct? So these three ratios help us to find the angle. So let us say if you are given hypotenuse and opposite side, in that case you can use sine, right? So we know sine of the angle, let us say angle A, sine of angle A will be equals to ratio of opposite over hypotenuse, which is A over C, right? Now from here we can say what angle A is. We can say angle A is equals to sine inverse of A over C, correct? So that is how you can find one angle. Once you find an angle, then you can find the other angle, because the sum of three angles is 180, correct? So angle B will be equals to 180 degrees minus 90 degrees minus angle A, right? Now 180 minus 90 is 90 degrees, so we can actually find 90 degrees minus angle A, right? We also say that angle A and B are complementary, right? So they are complementary angles, A minus B we can always find, right? Now, so that is how you can solve the triangle, right? So given any two sides, we can find the third side, and when we know three sides, then we can use any two sides to find the angle. For example, here we use sine A to find angle A, right? We could have used tan A also, right? Let me write expression with tan A. So you could have done tan A is equals to opposite over adjacent. So in this case, A over B, right? So it is A over B. That gives us angle A is equals to tan inverse of A over B, right? So that gives you angle A, and from there you can find angle B as 90 minus angle A, correct? So that is how you can solve a triangle given two sides, correct? Now that is the first option which we discussed, right? Let me call this as option A, right? Now let's discuss option B. In option B, we should be given at least one side and one angle, any angle. So we should know one side and one angle. Correct? Any angle. So let us say one angle is given to us, right? So let's see how are we going to solve in this case. Let's say we are given one angle. Let's say we are given angle A, right? Then what is angle B? Then angle B will be 90 degrees minus angle A. So we know all the three angles, correct? Now to find each and every side, we can find with reference to trigonometric ratios. So we are given one side also. Let us say we are given opposite side. Now if we are given opposite side, then we should use either sine or tangent. If we are given opposite side, we should use sine or tangent. So just remember that part. So let's go back to our SOHCAHTOA, right? Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tan is opposite over adjacent. Now let us say we are given opposite to angle A, right? If we are given opposite to angle A, then we could use either sine or tangent to figure out the answer, right? And once we know one side, right, then we can find the other side using Pythagorean identity, correct? So we can do this calculation and solve our triangle. So I hope you understand what are we trying to say, right? Let us say if you are given angle A and the adjacent side, in that case you can use cosine or tan, right? Both have adjacent side in them. So by using cosine you can find hypotenuse, and by using tangent you can find the opposite side. So that way you get all the three sides. Do you understand? So this is the way to solve a right triangle. So remember, whenever we are talking about solving right triangle, we are actually giving you with one of these options, two sides of a triangle or one side and one angle. And this is the process of solving. Now, in this set of videos, we have about 10 questions where we are going to solve triangles, the right triangles, practice, and then move on with acute angle triangles. Thank you and all the best.